8.5. Define and apply secure coding guidelines and standards. And here we are at the last domain, unless you're one of those guys who goes, I think I'm going to start with the last domain first. But other than that, it's been awesome. I hope you've enjoyed it as much as I have. All right, well, let's get started. And if I don't go deep enough into a topic, oh my gosh, hopefully you're an AI whisperer. All right, we have 4 subtasks here. 1. Focus on security weaknesses and vulnerabilities at the source code level. 2. The security of application program interfaces. 3. Secure coding practices. And 4. Software-defined security. Each of these subtasks is crucial for understanding how to implement and maintain secure coding standards. 8.5.1. Security weaknesses and vulnerabilities at the source code level. This subtask is critical for understanding how vulnerabilities at the code level can impact your application's overall security. For the exam, you'll need to be familiar with some common vulnerabilities and how to mitigate them. And you definitely want to be aware of the OWASP Top 10. It's one of the most important references for the top 10 web application security risks, from SQL injection to buffer overflows and cross-site scripting. Injection flaws, such as SQL or any other code or command injection. Major concern. To prevent them, you need to implement proper input validation and use parameterized queries. These flaws are frequently tested in the exam because they remain among some of the most critical and common flaws in web applications. Authentication and access control. Weaknesses in authentication mechanisms and access control can lead to unauthorized access and privilege escalation. Secure coding practices should address these issues, particularly around session management and authorization processes. Sensitive data exposure. Detect and fix improper handling of sensitive data. This includes using encryption for both data at rest and data in transit. Cross-site scripting. Another key vulnerability often exploited in web applications. Proper output encoding and content security policies are essential for preventing cross-site script attacks, especially when handling untrusted data on web pages. 8.5.2. Security of application program interfaces. Larry's favorite topic. As APIs have become an integral part to modern applications, securing them is critical, both for real-world security and for the exam. We're going to talk about and make sure you understand authentication and authorization. APIs must implement strong authentication mechanisms like OAuth 2.0 or JSON Web Tokens to ensure that only authorized users or systems can access APIs. Fine-grained authorization controls and further ensure that even authenticated users have only the access they need to and when they're permitted to see or do so. Input validation and sanitization, a common theme in secure coding. APIs need to strictly validate and sanitize all input to prevent injection attacks. Rate limiting and throttling. Implementing rate limiting and request throttling protects APIs from abuse, such as denial of service or excessive use that could degrade performance. This is a security measure that's often overlooked, but critical for maintaining availability of services. Encryption and data protection. Always ensure that APIs use HTTPS TLS for securing data in transit, and sensitive data is properly encrypted at rest. Avoid exposing sensitive information through API responses, logs, and another frequent topic on the exam. Monitoring and logging. Implementing real-time monitoring and comprehensive logging is essential for tracking API usage and detecting anomalies that could indicate misuse at the security or a security breach. Logging also supports forensics analysis in case of a security incident. APIs are increasingly becoming the backbone of modern applications, and their security is integral to protecting sensitive data and system functionality. The principles we've discussed here, authentication, input validation, and encryption, are recurring themes, and so mastering these concepts will help you in many areas. And if you want to learn more or go deeper, you know what to do. 8.5.3 Secure Coding Practices. Fundamental principles that help ensure software is secure from the outset. For the exam, it's important to know not just what these practices are, but how to apply them effectively. Input validation and output encoding. Secure coding begins with properly validating all data inputs. This prevents many common vulnerabilities like injection attacks. Additionally, using context-specific output encoding helps prevent cross-site scripting by ensuring that untrusted data is properly handled when displayed. Principle of least privilege. It's standard throughout the exam, and it's critical for secure software design. Software components should be designed to operate with the least amount of system privileges necessary. By limiting access rights, you reduce the potential damage that could occur if an attacker gains unauthorized access or just an accident should happen. Secure error handling and logging. Proper error handling ensures that sensitive information isn't exposed in error messages. Logging practice must also avoid exposing sensitive data, and logs should be stored securely to ensure that they're tamper-resistant and available for auditing in case of an incident. Regular code reviews and static analysis. Conducting regular peer code reviews focuses on security and helps identify potential vulnerabilities early in the development process. Additionally, static code analysis tools are used to automatically detect security issues in the source code, allowing you to address them before they become real problems. These secure coding practices are designed to create a foundation of security that integrates into the entire software development lifecycle. 8.5.4 Software-Defined Security. This is a more advanced concept that brings together many of the ideas we've discussed so far, and it's definitely something you should understand for the exam. First, let's define the concept. Software-defined security is about managing security policies and controls through software rather than using specific hardware, firewalls, routers, etc. This flexibility is crucial in modern dynamic IT environments. Automation is the key benefit of software-defined security. For the exam, understanding how this automation can improve the security posture by ensuring consistent policy application. The flexibility of software-defined security is our next point. This allows for rapid adjustment of security controls across the entire network. The exam may test your understanding of how this agility benefits overall security management. Centralized management is another critical aspect. This ties back to the principle of consistency in security controls, which is a recurring theme in the exam. And lastly, we have an example with VMware NSX. Now, while the exam isn't vendor-specific, understanding real-world applications of these core concepts can help solidify your knowledge. And as we wrap up this task, notice how software-defined security embodies many of the secure coding API security principles we discussed. This interconnectedness is key for the holistic security approach that the exam emphasizes. All right, wrapping up Task 8.5, Secure Coding Guidelines and Standards. We talked about implementing secure coding guidelines. Enforcing secure coding practices is essential for preventing vulnerabilities at the source code level. This includes applying the OWASP Top 10 recommendations, practicing input validation, and securely handling sensitive data. Focus on API security. APIs are a common attack vector, so strong authentication, input validation, and encryption practices must be enforced to safeguard them. The principles of rate limiting, logging, and real-time monitoring are also crucial to maintain API security. Adopt secure coding practices. These include the principle of least privilege, secure error handling, and regular code reviews. Static analysis tools should also be leveraged to detect potential vulnerabilities very early in the development process. Leverage software-defined security. SDS provides flexibility by allowing security policies to be centrally managed and dynamically enforced across both physical and virtual environments. Automation plays a key role in enhancing the security posture through predefined rules and real-time adjustments. And continuous improvement. We know security's never set it and forget it, right? Same with secure coding. We have to put this into a part of our lifecycle management process and ensure ongoing improvements. All right, we did it. Let's try it out with our prompt at the end. And I'll tell you, I learned a lot doing this thing, so I hope people enjoy this. All right, if you're here and 8.5 wasn't the first module you decided to watch, I thank you very much for making it all the way through here. This was so fun. Arpita Gandhi, my partner, asked me to do this a few months ago, and I was very resistant. I looked at all the redundant stuff in there, and she said, nah, I think you should do it. I asked the LLMs, and they said you should do it. And I said, well, how did you ask them? I'll be the one to judge. But they, yeah, that would probably be a good idea, Larry. And man, it was a good idea, at least for me, to learn so much, and that includes script writing, script reading, and working more with the AIs, refining this prompt, and of course the CISSP content. I learned a couple of things that I didn't know. All right, thank you so much. Live long and prosper, and I'd love to hear from you guys.